So in the circuit below, okay, use Ohm's law and Kirchhoff's laws to find I0. That's question 1. Question 2, calculate the power absorbed or supply by each element in the circuit. Okay, so what is the circuit? The circuit has two sources. So we have 120 volt source, voltage source. We have 10 ohms. We have 50 ohms. And then we have a 6 amps constant current source. Okay, and I0 that we're looking for is the current in here. Now that's flowing through the 10 ohm resistor. Okay, so solutions. Okay, now so to apply KCL, okay, let's find and label essential node. Okay, so let's remember, essential node. So an essential node, right? So from the previous video that we define an essential node is a node is a point where 3 or more component or more element are joined. Okay, so the reason why we wanted to find essential nodes is that we wanted to end up with the minimal set of equations to solve the network. So we're going to do this a few times, right? So in all my videos where I will apply Kirchhoff current law, I will make sure that I'll follow the same steps so you get used to it. Okay, so the steps will lead you to get a minimal set of equations, right? And that will lead you to solving for the current easily. Okay, so essential nodes. So let me redraw the network. So I'm gonna redraw the network here. We have 120 volt, and I have 10 ohms, and the current to the 10 ohms, that's I0. Okay, and we have the 50 ohms, and then the 6 amps current source. Now, how many essential nodes do we have here? We have 2 essential nodes. We have 2 essential nodes. Okay, we call this A, and I call this G. Okay, so when we wanted to apply KCL, step 1, right? Step 1, find and label our essential node. Okay, so we have 2 essential nodes, and one of them will be used as reference. Okay, so usually the one that has more connections, that's what we use as a reference, but here I'll use ground as reference, so 0 volt. Okay, so I label. So in step 2, okay, give a reference direction to current in each branch, to the current in each branch. Okay, so we know I0, that's given to us. I'm gonna call this I1, and I am going to call this I2. So then step 3, okay, write KCL equation at each essential node. The remaining essential node. All right, so we have ground, and whatever we have left, write KCL at each essential node except ground. Essential node except at the reference node. Okay, so that means this is step 3. So KCL at node A. So sum of the current come in, and sum of current entering node A equals sum of current exiting leaving node A. So what is that? That is I0 plus I2 equal to I1. So that is my equation, but you agree with me that I2 equal to 6 amps, right? Is that current in that branch? So I2 equal to 6 amps. Now let's write KVL. Okay, so this is I0 plus 6 equal to I1. Okay, so this gives me one equation, two unknowns. This gives one equation, two unknowns. Now we need another equation, okay, so that we have two equations, two unknowns, and then we can just solve those equations to find the current I1 and I2. Okay, so now let us apply KVL, right, to obtain the second equation. The second equation. Okay, so now let's find a loop. So I'm gonna use this loop. Okay, now call this one. So KVL, KVL around loop 1. So starting from, okay, so we're starting from the ground node. So we're going to move like that, right? So we're going to move like this. So starting from the ground node, we come across the negative polarity of the voltage, so negative 120 volt. Okay, so to apply KVL, I think I need to also do this to be I need to be very systematic about this as well. So to apply KVL, okay, let's do the steps. So we are going to level the voltages. Okay, So let's say this is a V 10 ohms and this is a V 50 ohms, or if you want, I could call this V1 and V2. Okay, so we're going to do more examples, and that you are going to, so maybe let me use a different color. All right, so this is 10 ohms. Let me use a different color to label the voltages so there's no confusions. So let's use red. Call this V1 and I'll call this V2. Okay, so as we give that direction, reference direction to current, we can also give reference polarity to voltages, right, when we apply KVL. So step one, right, we are going to label voltage across the component, right? So step one, label voltage. I'll give polarity to voltages across each component. Okay, so label the polarity for voltage, for the voltage across each component. The voltage across each component. So using this loop that I call one, so in step two, write the KVL equation for each loop. Okay, so we have, starting from the bottom, okay, starting from the bottom, okay, so moving upward, starting from there. Okay, so what do we got? So when we move, we come across the negative polarity of the 120 volt first, so negative 120 volt plus V1, right? Because we come across the polarity the positive polarity of V1, and then plus V2. That complete the loop, right? So we started from there, and then we come back to ground, so that is equal to 0. Now we're going to write the Ohm's laws. Okay, so now write Ohm's law. So now, what is V1? We know that we have the 10 ohms resistor, that's I0, and we have V1, then we have 10 ohms. So when we write Ohm's law, V1 is 10 times I0. right? So we have that passive sign, and then we have the 50 ohms. Okay, and the current through that 50 ohm is I1, and we label the polarity of V2 as such. So V2 will be equal to 50 times I1. So I'm gonna take these two and substitute in this equation. So negative 120 volt plus 10 I0 plus 50 I1, that is equal to 0. So that gives me my second equation. I have the first equation here. Okay, so together we have I0 so we have I0 plus 6 equal to I1. So I0 plus 6 equal to I1. So that's equation number 1. So let me put those two equations together. We have 10 I0 plus 50 I2 equal to 120, and I0 minus I2 I1 I0 minus I1. Oh, this is 50 I1, sorry. So I0 minus I1 equal to negative 6. Now the top equation, I can divide the whole equation by 10, so that gives me I0 plus 5 I1 equal to 12. Then I have I0 minus I1 equal to negative 6. So this equation will be easy to solve. If I negate this equation and then I add the map, I have 6 I1 equal to 12 plus 6. So that's 18. So I1 will give me 3 amps. Okay. So then what is I2? What is I0? So I know that I0 is negative 6 plus I1. So I0 equals to negative 3 amps. Okay, so now let me redraw the network here, and then we're gonna answer. So question 2. You have 120 volt, and we have 10 ohms, and the voltage is level V1, I call this V2. That's how I call it. I call it the 50 ohms. And the current source is 6 amps. Okay, so the voltage here will be also V2. So when we have element that are connected like this, so this is 1 and this is 2, right? They share this common node. So the voltage here, V, will be the same voltage here, V. We say that these two are in parallel. Okay. So we know the current here, I1, just 3 amps. We know I0. I0 equal to -3 amps. So here we're asked to calculate the power. So I'm going to calculate the power for each. So power absorbed or supply by each component. Each element. So I will start with the source, the voltage source, the constant voltage source. So we have 120 volt. Okay, and the current here is I0. Okay, so let's calculate P. Right, so if I look at this as just a component, we know that I0 is flowing this way and the voltage is level like this. So passive sign convention, okay, so P of the 120 volt source is the current is flowing from minus to plus, so negative 120 times I0. So that gave me negative 120 times I0 minus 3 amps. So that gives me 120 times 360 watt. So P just 120, P of the source, 120 volt source, just 360 watt. It's positive, so that means the independent voltage source absorb power. So the independent voltage, so 120 volt source, the independent voltage source absorbs 360 watts. Okay, so let's look at the 10 ohm resistor. Okay, now the 10 ohm resistor. So for the 10 ohm resistor, have I0 and have V1. So V1 equal to 10 times I0. So that means is 10 times -3 amps, which is -30 volt. So if you look at this as a component, the current is flowing from plus to minus. So P is V1 I0. So V1, which is -30 volt, times I0, which is -3 amps, which is 90 watts. P of the 10 ohms. Okay, so what conclusion can we draw? The 10 ohm resistor absorbs 90 watts. Okay, now the 50 ohm resistor so the 50 ohm resistor also have I1, and then we have V2. So V2 is 50 times passive sign convention. The current is from plus to minus. So 50 times I1, which is 150. Right, so 50 times 3, which is 150 volt. So P is V2 I1, so that is 150 times 150 times 3, so that is 450 watt. So P of 50 ohms. Okay, so what conclusion? The 50 ohm resistor absorb 450 watt, right? Because that's positive, right? The conclusion is that because this is positive, that's why we absorb. Okay, and here it's positive, that's why we say it's absorbed. Now the last one, the 6 amps current source. The 6 amps current source. So the current source is like that, and the current is I2, which is 6 amps, and the voltage across it, as we say, was V2. So if I look at it as a component, So we have I2 going this way, and the voltage is level like that. So P 6 amps will be equal to, because of this polarity, current is flowing from minus to plus, so minus I2 V2 I2 V2 I2, so minus V2, which is 150 volt, times I2, just 6 amps, so that will be negative 900 watt. So P is less than 0. Is less than 0. This implies that the 6 amps current source supplies 900 watts to the circuit. Okay, so we know that the power supply, okay, so sum of supplied power equal to sum of absorbed power. So we wanted to check that. Okay, so the supply power is 900 watts. The absorbed power, we have 90 watts. The first one is 360 watt. 360 plus 90 plus 450 0 360 plus 90 plus 450. So let's add them up and see. So this is indeed 900 watt. Okay, so I want you to keep this in mind. When you calculate, you're going to come up with, when you add them up, you're going to get the same result. Okay, so I'm going to stop right here, and I'll do another example, a couple more examples in a separate video. Please subscribe so that you don't miss any of the videos that I'll post after this. Thank you.